So, dear students, let us continue our discussion on problems of motion in a straight line. And till yesterday, we have discussed 5 problems, and this is the 6th problem that I'll be taking today. Okay, the question is as follows. A stone dropped from the top of a cliff reaches its foot. Okay, a stone dropped from the top of a cliff reaches its foot in 4 seconds. Calculate the height of the cliff and the velocity with which it falls. So here what we have is a cliff. Okay, what is a cliff? It is somewhat like this, an end which we see for the landscape. So here a stone falls from the top of the cliff. So this is the top of the cliff and this is the bottom of the cliff. And a stone falls from this top of the cliff to bottom of the cliff, right, in 4 seconds. So time taken for the stone to reach the foot is 4 seconds. What we need to calculate is height of the cliff and the velocity with which it reaches the foot, or velocity with which it falls down, which means the final velocity of the motion. So it is gently dropped from the top, which means it is not thrown downwards. Instead, it is just like left freely from the top of the cliff, and hence it falls down to the bottom of the cliff with certain velocity v. How about the initial velocity? Initial velocity of this motion from here to here is 0 meter per second. And acceleration due to gravity for this is body moving in downward direction under the influence of gravity. So A is equal to plus G, which is equal to 9.8 meter per second square. And now it's time to calculate h, which itself is the height, which itself is the distance travelled, right? Height of the cliff itself is equal to the distance travelled by the body from here to here. So there are 2 formula for finding the s value, which is s is equal to ut plus half at squared, and the other is v squared minus u squared is equal to 2as. Since I know what is a, I know what is u, and I know what is t, I am going to take s is equal to ut plus half a t squared formula. Now what is u? Initial velocity is 0 into t plus half into a acceleration. Acceleration with which the body falls from here to here is 9.8 into t squared 4 squared. Okay, that's it. 0 into anything is 0. What is left is half into 9.8 into 4 squared. 4 squared is 16. So 16 by 2 is 8. 8 into 9.8. So S is equal to displacement is, the final displacement is, you can make use of calculator to calculate it, it would be 78.4 meter. So this S is the displacement of the stone from top of the cliff to bottom of the cliff, which itself is the height of the cliff. So S is equal to 78.4, which itself is h is equal to 78.4 meter. Okay, so that's it. We have S with us. One of the factor is calculated. Moving ahead for the next, we need the final velocity of the stone when it reaches the ground. So very simple. The first equation of motion says v is equal to u plus a t. So v is the final velocity, u is the initial velocity, a is the acceleration of the body, t is the time taken. U is 0 plus acceleration is 9.8, time taken is 4 seconds. So velocity of the body of the stone with which it reaches the ground is going to be 39.2 meter per second. So the speed with which the stone drops down, reaches the bottom of the cliff is 39.2 meter per second. This is about sixth question. Moving ahead, this is the seventh question that we have. A stone is projected vertically up with a velocity of 40 meter per second. Find the maximum height reached by the stone, height of the stone at the end of 2 seconds, velocity of the stone at the end of 3 seconds, the total time for which the stone was in air. Okay, this is the situation where a stone is thrown upwards from the ground. With what velocity? With the velocity, initial velocity of 40 meter per second. If we throw a stone upwards, vertically upwards, the stone starts losing its velocity and loses its velocity completely at certain point in midair and starts to fall again backwards, fall back towards the ground. Right? This is the complete motion of the stone when we throw a stone upwards like this. Say h is the height travelled by the stone during its journey. At this point, the topmost point of the journey, the stone will have 0 velocity. So, if I consider this is the initial point of motion and this is the final point of motion, then initial velocity will be 40 meter per second, final velocity will be 0 meter per second. H is the total height achieved or travelled by the stone. And now we need to calculate this h in the first place, maximum height reached by the stone. So, how about acceleration? Since the stone is traveling upwards like this, acceleration will be minus g, which is equal to minus 9.8 meter per second square. So now maximum height reached by the stone shall be calculated using the formula. See, we need to find h. What is h? H is displacement of the body from here to here. So we need to find s. What do we have with us? We have the value of v, we have the value of u, we have the value of a. So we need a formula which will connect u, v, a and s, which will be v squared minus u squared is equal to 2as. Now, what is v? V is 0. So 0 squared minus what is u? U is 40 squared is equal to 2 times what is a? A is minus 9.8 into s. What is s? S itself is the height of the or maximum height achieved during the journey. So now what is 40 squared? 40 squared is 1600 is equal to 2 into minus 9.8 into h. So 2 ones are 2, 800s are 800 by 9.8, negative sign cancels. So h is equal to 800 by 9.8, which will be equal to 81.64 meter. So this is the maximum height travelled by the stone from here to here. First part of the problem is solved. How many parts do we have? We have 4 parts, or I can say 4 sub questions. Let us go for the second sub question. Height of the stone at the end of 2 seconds. So for the second sub question, they have given us the time in which, after which we should find the height. Okay, this is the maximum height. For the second question, they are asking us to calculate height, okay, or displacement, which itself is displacement, after 2 seconds. Okay, initial velocity remains the same, acceleration remains the same. This time, instead of v, final velocity, we have the information about the time taken by the stone. So once again, we need a formula which will give us the connection between s, t, u and a, which is s is equal to ut plus half a t squared. So now S itself is h, u is 40 meter per second into time is 2 second plus half a is minus 9.8 because it is thrown upwards. You should consider the negative sign, okay, minus 9.8 t squared into 2 squared. 2 squared is 4, okay, let me write it. 40 into 2 is 80, minus into plus minus, 2 ones are, this will 2 squared will be 4, 4 by 2 is 2, 2 into 9.8, it will be 19.6. So now h will be equal to 80 minus 19. 80 minus 19.6, which will be 60.4 meter, which means after 2 seconds the stone has travelled a distance of 60 kilometer or 60 meter somewhere here. Okay, so this is the answer for second sub question of 7th question. Moving ahead for the third sub question. In the third sub question, we have to calculate the velocity at the end of 3 seconds. Final velocity. So it is simply v is equal to u plus at. V has to be calculated. U is simple 40 plus a is 9.8 minus 9.8. Keep that in mind because the body is thrown upwards, into t. What is t? See, after 3 seconds. Themselves has given that we have to calculate the velocity after 3 seconds of journey. So into t, it's equal to 40 minus, okay, what is t? T is 3 seconds. Let me put 3. Okay, plus, sorry, not plus, plus minus into plus minus 9.8 into 3, which will be 29 0.4. Okay, and you subtract them, and hence the final velocity will be 10.6 meter per second plus, okay, plus 10.6 meter per second. So this is the final velocity of the stone at the end of 3 seconds. That is about third sub question. And the final question, the total time for which the stone was in air. What is the total time for which the stone was in air? See, as in when the body of the stone was thrown upwards, it went in air, right? Yes, it is in air, it is in air, it is in air. It reaches the topmost point and falls back to the same point. So this is the complete motion, and during this entire motion, the stone was in air. And this entire motion of moving upwards and again falling downwards can be divided into two parts. In the first part, we can put it from of from the bottom to the top, and the second part shall be taken as from the top to the bottom. And for both the motions, from from the bottom to the top of the uh, from the bottom to the top and from top to the bottom, both the motions will take same time. and they will cover same distance, isn't it? When I throw a stone upwards, the stone will take the same amount of time to reach the top from the bottom, and it will take the same amount of time again to reach the bottom from the top. So, the total time for which the stone was in air is equal to 2 times the, since this it's same, 2 times the time for which time taken by the stone to reach from the bottom to the top, right? Total time is from bottom to top, top to plus, from bottom to top plus top to bottom again. Now the time taken to move from bottom to top is equal to time taken to move from top to bottom, and hence I can take the total time taken is equal to 2 times the time taken by the body to reach from bottom to the top, which shall be taken as, okay, let me take the total time taken as t dash, okay. So t dash is equal to 2 times t. What is t? T is the total time taken, not the total. T is the time taken by the body to go from bottom to the top. So we have to calculate the time taken by the body to reach the topmost point, which means the motion begins here and ends here. So for this motion, initial velocity u 40 meter per second, final velocity v 0, because at topmost point velocity is 0, right? When you throw a body, it reaches the topmost point, and there at the topmost point final velocity becomes 0 for a while, and again, and after becoming 0 it starts falling down again. So for certain time velocity will be 0, and acceleration is minus g, which is minus 9.8 meter per second square. What we need to calculate is time taken. Very simple, we have the formula, first equation of motion, v is equal to u plus at, and from this what is v? Final velocity, which is 0, which is equal to u, which is 40, plus a is minus 9.8, t shall be found. So from this I can take minus 9.8 into t to the LHS, and hence it becomes plus 9.8 t is equal to 40, and hence t is equal to 40 by 9.8, okay, 40 by 9.8, which is equal to, which is nearly equal to 40, not 40, 4.71 second, okay. You can make use of calculator to get the exact value. This is fine. So that's it. We have all the solutions for the given questions. We had 4 questions given and 4 answers. Keep the answers in box. Total height for the entire motion is 81.64 meter, and the displacement or the height after 2 seconds is 60.4 meter. Somewhere here it will be after 2 seconds, and velocity after 3 seconds will be 10.6 meter per second. Now, sorry for that. See, this is the time, 4.71 seconds is the time taken by the body to reach the top from the bottom. Now it should come back to the bottom. So for this return motion, it will take the same time. So t dash is equal to 2 times t, which is 2 into 4.71, which is equal to 9.42 second. Okay, this is the time for which the stone was in air. Okay, this is the final answer, not this. This is the time for which the stone was traveling upwards, was going upwards, and the same time it will take to come or fall back down, right? So total time taken is 2 times of this, which is 9.42 second. So this is about the solution. for 7th question. Okay, going ahead for the next question. Question number 8 is as follows. A bullet is fired normally to the wooden plank of 0.5 meter thickness. Initial speed of the bullet is 100 meter per second and it emerges out with a speed of 50 meter per second. Find the deceleration of the bullet and also the time for which the bullet was in contact with the wooden plank. So, in this problem what we have here is a wooden plank, which means piece of wood or bulk of wood, I can say, like this. And a bullet is hit normally. Okay, normally means like this, exactly like this. Exactly perpendicular to the surface, normal means. Okay, a bullet hits the one surface of the wooden plank with the speed of 100 meter per second. So, when the bullet hits this point, its speed is 100 meter per second. Then from this point onwards, obviously the bullet enters the wooden plank and starts reducing its speed. Right? The bullet, by the time reaches the opposite surface, the speed of the bullet will decrease, 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 and when the bullet comes out of the wooden plank from the other end of the wooden plank, okay, its speed is found to be 50 meter per second. Right? When it comes out, it is 50. When it enters, it is 100 meters, 100 meter per second. At this point, when it comes out, it is 100 meter per second, and it is given that the thickness of the wooden plank, okay, the thickness of the wooden plank, which is this value, okay, from here to here, how thick it is uh, given by 0.5 meter. Okay, 0.5 meter is the thickness. So this is the given data. Now what we need to calculate is deceleration of the bullet, which means acceleration of the bullet. We should calculate acceleration, then we shall remove the negative sign and keep the deceleration. And also time for which the bullet was in contact with the wooden plank, which means time taken. Now coming to this motion, this is a motion in a straight line with the initial speed of 100 meter per second and final speed of the motion is equal to 50 meter per second. And the distance travelled by the bullet is equal to thickness of the wooden plank, right? More the thickness, more the distance travels. More lesser the distance, lesser the distance travelled. So thickness is equal to distance travelled. So S is the distance travelled symbol, which itself is equal to distance travelled by the bullet when it goes through the wooden plank. So S is equal to 0.5 meter. And now you have displacement, initial velocity, final velocity, and yeah, initial velocity is 100 meter per second, u is equal to 100 meter per second. Final velocity is v is equal to 50 meter per second. So very simple. Now let us calculate a first. See, we have s, u and v. We need to find a, which is the formula v squared minus u squared is equal to 2as. What is v? V is 50 squared minus what is u? U is 100 squared is equal to 2 times acceleration has to be found. S is 0.5. Okay, that's it. So 50 squared is 2500 minus 100 square is 10,000 is equal to 2 into 0.5 is 1. So it is going to be simply a which is left in the RHS. 2500 minus 10,000 will be minus 7,500 meter per second squared. Huge acceleration, a very huge acceleration uh, of the bullet, which is this much, minus 7,500 meter per second squared. So one of the value is calculated. Next, time for which the bullet was inside the wooden plank. So we have final velocity, acceleration and initial velocity. We need time, and hence V is equal to U plus AT formula will help us in calculating time. Final velocity 50 is equal to initial velocity 100 plus acceleration minus 7,500. Time has to be calculated. And now 50 minus 100 is minus 50 is equal to minus 7,500 t. One of the 0 gets cancelled, negative sign gets cancelled, t is equal to 750, t is equal to 5 by 750. Now simplify this, you get 1 by 150. So the time taken, or time for which the bullet was in contact means inside the wooden plank, is equal to 1 by 150, which is equal to 60, 0.00667 second. Very small time. You can make use of calculator to find this. So that the time taken, or time for which the bullet was inside the wooden plank, is 0.00667 second. That's it. This is about 8th question. Next, question number 9, an easy question. A particle moves in a semicircular path of radius 14 centimeter. Calculate the distance travelled and displacement. So now, here is a particle which is travelling in a semicircular path. The radius of this semicircular path is found to be given as 14 centimeter, and the distance travelled and displacement has to be calculated. Okay, this is the path of the body. We all know that distance is the length of the path travelled. Okay, this is the initial position, this is the final position. Say this is a point on the line. Let me take the point as C. So along ACB, when it goes arc ACB, okay, arc of AB, if I take, that itself is the distance. Okay, therefore distance is arc length of ACB, right? Arc length of ACB, which is, since ACB is a semicircle, the length will be equal to pi r, right? If it is a complete circle, then it would be 2 pi r. Now it's a semicircle from here to here, so it is simply pi r. What is pi? Pi is 22 by 7 into what is r? Radius is 14 centimeter, which is equal to 7 by 7 ones are 7 twos are 44 centimeter is the distance travelled by the body. Okay. Next, how about the displacement of the body? Displacement is the shortest distance between A and B, shortest length between A and B, which is the diameter, right? So displacement is equal to length of the line AB, right, which itself is the diameter, which is equal to, what is AB? AB is the diameter, which is equal to 2 times, this is O, 2 times AO, which is radius. AO is radius, so 2 times 14, which is equal to 28 centimeter. That's it, very easy. Therefore, displacement of the body is 28 centimeter for this motion. Very easy. Once again, one more easy question here. A car moving from rest acquires a velocity of 30 meter per second in 5 seconds. Calculate the acceleration and distance traveled. So, the factors, given factors are as follows. Initial velocity is given u, which is 0 because it is starting from rest. So, initial velocity is 0 meter per second. Acquires a velocity of 30 meter per second, which means the final velocity of the motion is 30 meter per second. In what time? In the time of 5 seconds. 5 seconds. What we need to calculate is acceleration and displacement or distance traveled. Both are one and the same. And now let us go for acceleration first. See, we have the formula v is equal to u plus at, upon rearranging which we get v is a is equal to v minus u by t. We can directly take this formula, that is fine. What is v? Final velocity 30, u is 0 by time 5 seconds. So 30 by 5 is 6 meter per second squared. This is acceleration. Now displacement shall be found. Formula for displacement is s is equal to ut plus half a t squared. Initial velocity is 0, 0 into t is 0 plus half a we have calculated 6 into t squared, which is 5 squared. 0 into anything 0, half, 2 ones are 2 threes are. 5 square is 25, 25 into 3 is 75 meter. So acceleration is 6 meter per second squared and the displacement is 75 meter. And this is the 10th question. Okay, we have uh, 12 questions more in this chapter, and we shall take the remaining questions in the next session. Okay, and in 2 more sessions we will complete all the numerical problems of motion in a straight line. Thank you.